Welcome to lesson 15 of GMAT Math Basics. If you don't want or need help with math basics, just head back in the feed for some more advanced topics. Today, let's talk about the basics of percents. Quick quiz. What is a percent? Can you define what a percent is? Second question we'll answer today. How do I calculate a percentage of something? For example, how do I calculate 38% of 50? Third question we'll answer today is what is percent change and how do I calculate it? We'll also answer the question, how do I calculate percent interest? And we'll also discuss what it means if interest compounds. For example, what does it mean if interest compounds annually versus biannually versus quarterly? If you already can answer those questions confidently, you may want to move on to the next lesson. If you cannot or you want to understand these topics deeper, that's what we're going to cover right now. So first question, what is a percent? Think about the words per and cent. Per means for every, such as I'm doing 6 workouts per day. That means I'm doing 6 workouts for every day of the week. Think about the sentence, we're pitching 3 deals per week. Every week we do 3 deals, or it's 3 deals for every week. The word cent means 100. So we put those together. Per cent means for every 100. That should help you recall that percents generally signify a fraction out of 100. It's a useful way of comparing quantities without comparing the actual specific quantities themselves. For example, we could say that we earned $10 million in revenue last year and that this year we earned $12 million. And that's very useful in certain situations. But other times, we might want to say we had a 20% increase in revenue. What exactly does that mean? Well, that means for every $100 of revenue that we earned last year, this year we earned $120. So again, for every 100, that's a 20% increase in revenue. You could also think about it as we have 87% market penetration. What that means is almost 9 out of 10 people who could use our product or service actually do use it. And if you think about it, sometimes that's more useful than saying 87,000 out of 100,000 potential customers use our product. Even though, obviously, using actual numbers is really important sometimes. For example, if we say we have 90% market penetration, that sounds really good. But if the market size is only 20 people, well, maybe that's actually not that great. So obviously, all of you are accomplished business people, or at the very least on your way to becoming accomplished business people through this process. And you probably understand all of this super well. I'm just talking about it to help drive home the basic definition of percents, which is the count for every 100 units. Now that we've defined what a percent is, let's talk about using percents as operators. What does it mean to take a percentage of something? For example, what's 20% of 10? It's a common type of concept and question on the GMAT. And when you see percent plus the word of, that means multiply by the percentage. You can use a fraction or a decimal to do that multiplication, but basically of plus percent signifies multiply. So if we say, what's 20% of 10? That means multiply 20 over 100 times 10. Similarly, if you're asked to take 38% of 50, you can express this as 38 over 100 times 50 or times 50 over 1. I personally like to write it as 50 over 1. It helps me visualize and also helps me cancel common factors better. But that's it. That's how you take a percentage of something. In percent problems, of means multiply. That's worth remembering. Next up, what is percent change? As you might suspect, this measures how much something changes per every 100 units. Again, it's a useful metric because sometimes you want the actual change in number. Other times you just want to know the change relative to what is changing. So there's a time for absolute values and there's a time for relative values. There's actually a very useful formula to determine percent change, and I strongly, strongly recommend memorizing it. The formula is new value minus old value divided by old value, and then that entire thing multiplied by 100. Let me repeat that. New minus old over old, all times 100. One final time. New value minus old value over old value divided by old value, that whole thing times 100. A lot of people will tell you it's change over original times 100, and that is fine to do, but I'm really going to strongly recommend memorizing it the first way I told you. New minus old over old times 100. It's very easy to get confused under time pressure if you're just doing change over original times 100. Having said that, if you've been using change over original times 100 successfully, then by all means. If it's not broken, don't fix it. Now, we briefly spoke about flashcards last week. If you don't feel like you know how to make flashcards well, just jump on a quick web search or use your preferred artificial intelligence provider to get some instruction on that. And I would highly recommend making a flashcard for this concept of percent change and the formula associated with it. How might a percent change calculation look on the GMAT itself? Well, it could say something like, what is the percent change from 30 to 60? In that case, the new value is 60 and the old value is 30. We're going from 30 to 60. So we would do new minus old over old times 100. That's 60 minus 30 on top and then 30 on the bottom. 60 minus 30 on top is just 30. If we divide that by the old value, which is 30, we just get 1, and then we multiply that by 100, and that tells us that that's a 100% change. A 100% increase means you're doubling the value. If you changed it by 100%, that means you added all 100% of the previous thing. So now you actually have 2 of it. It's kind of an interesting concept. The GMAT doesn't always use this exact phrase percent change, but they might use the exact phrase percent change. And if you see that, this is the formula they're talking about. But they could also express it other ways. They might say something like 30 is what percent greater than 25. When you see that kind of situation, you want to think percent change, percent greater, percent less. All of those signify percent changes. And I'll have a more comprehensive list for you in a moment. But for now, the concept is what's important. If you see something with a than, with a percent and a than, such as 30 is what percent greater than 25, then you want to make the word that follows than the old value. It's a great little trick. So the thing or number or word that follows than is the old value. So if we did 30 is what percent greater than 25, then 25 is going to be the old value and 30 is going to be the new value. So let's do that math. We'd have 30 minus 25 divided by 25. 30 minus 25 on top is 5. So that would give us the fraction 5 divided by 25. If we reduce that, and if you need help reducing fractions, that's in a past lesson. 5 divided by 25, we're going to be able to reduce that to 1 over 5. 1 over 5 times 100 over 1 is just going to yield 20. And so 30 is 20% greater than 25. That's a great way to do those percent greater or percent less than calculations. Again, whatever follows than, use that as the old value. Might want a flashcard for that as well. Let's get into some of the other ways that they can describe percent change, because as you might suspect, things like percent less or percent fewer also qualify. So probably the list that would be comprehensive enough would be percent greater, percent bigger, percent larger, percent growth, percent loss, percent decrease, percent smaller, percent less, and percent increase. So I wouldn't necessarily recommend memorizing that whole list. It's more the concept of something getting bigger as a percentage or something getting smaller as a percentage. You just want to associate that with percent change. And then just, I recommend that you write right at the beginning of the problem when you see that new minus old over old times 100 right at the top of your scratch work. That should help a ton in terms of framing your strategy for the problem and also avoiding any mistakes. That's percent change. I recommend memorizing the formula and just remember once again that what follows the word than is the old value. So that brings us to the question, what is percent interest? Interest is really just a special type of percent change. Now, you can also use percent of calculations in interest questions, and so it helps tie those two concepts we were just discussing together nicely. Interest really measures how much an investment or a debt grows over time. Let's say you make a $100 investment that earns 10% interest. How much money does it earn? Well, if you want to know just how much interest you earn, that's usually a percent of calculation. So we would just multiply the $100 times 10 over 100. It earns 10% of $100, so that would be $10. Now, if you want to know the principal plus the interest that's been earned after you earn the money, that's usually a percent change calculation. For many people, that's already going to be intuitive, but if it is not intuitive for you, that could also be worth memorizing and or worth a flashcard. For example, if I put $100 into an account that earns 10% interest, and we assume that I'm not making any withdrawals from that, how much money is in the account after the interest is earned and paid? Well, the new value in the percent change formula here would actually be the thing we want to know. Now, we haven't covered algebra yet. We will soon enough. But I'm just going to use some very, very basic algebra here, and I'm just going to write the word new as a placeholder or variable to represent that's what we're looking for. The old value is 100, so that's simple enough. And so we would have new minus 100 divided by 100. And then we would multiply that whole thing times 100. And then we already know that the percent change is 10. So we can put that on the other side of the equal sign in the percent change formula. So again, percent change formula is new minus old over old times 100, and that equals percent change. In this situation, we want to know the new value. We know the old value is 100, and we know the percent change is equal to 10. So once again, I would have new minus 100 divided by 100, that whole thing times 100, and then equals 10. The hundreds cancel out. If I divide by 100 and then multiply that by 100, it's just going to leave the numerator by itself. And so we simply get new minus 100 on the left side of the equal sign and then 10 on the right side of the equal sign for the 10% change that we're looking to add on. Now, here's where we get into a little bit of algebra. We're going to add 100 to both sides. We'll cover algebra soon. You might just want to take my word that that works for the short run if you're not familiar with algebra yet, or if it's just been a minute. And so the new value is going to be $110. And you could see that's what would represent the value that's in the account after the interest has been accrued. Now, you don't have to use the percent change formula to do these interest calculations if you have another way of doing them, or if you're comfortable doing them in a way that works and that's already getting you the result on the exam that you want to see. Perhaps, obviously, many of you in this field are going to understand percentages extremely well. Some of you might not, though. So if that's you, or you just want to have a bulletproof process, if you want the interest itself, think percent of. If you want the total amount after the interest accrues, think percent change. Now, this type of interest that I'm talking about now, where we just earn the $10 on the $100 principal, and that's called simple interest. Simple interest basically just means it happens one time, or you could think of that as no repeating. $100 earns 10% interest once, and that's the end of that story. That's simple interest. But there are situations on the GMAT where the interest could repeat, like the kind of interest that you might get if you invest in a stock over a long time horizon. That's called compound interest. Both are tested. So simple interest means it just happens once. Compound interest means it repeats. That brings us to our next question. What is compound interest? Simple enough. And just to repeat it one more time, compounding means repeating. Compound interest adds interest repeatedly, usually at set time intervals. For example, you might make an investment that compounds annually. That means every year you get paid the interest. Then the next year you earn interest on that increased amount from the previous year. It's a very helpful concept and helpful tool for building wealth. Let's say we invest $100 at 10% interest, but now instead of it being simple and just happening once, let's say it compounds annually. So that means it repeats one time per year. And let's say that we leave the money invested for 2 years. Well, at the end of the first year, you would get paid 10% of $100, which is $10. And so you would have $110 in your account. But at the end of the second year, you would get paid 10% of the $110 from the previous year. 10% of 110 is $11. So at the end of the second year, you would have $121 in your account. What that means is compounding annually got you an extra dollar, or if you like, an extra 1%. And this is part of the reason that a lot of people seek out investments that compound over time. Compounding gives you extra leverage on your capital. If we just had simple interest twice on our $100, we would have had only $120. But because we got compounding interest, we got an extra dollar. On the GMAT, compounding annually is fairly common. So you should be comfortable with that. But there are also other types of compounding interest tested. And I think it's worth knowing two other types. First is compounding biannually. That means twice per year or once every 6 months. The second is compounding quarterly. That means it's compounding 4 times per year or once every 3 months. Let's start with compounding biannually and how that works. Here, what you're going to do is you're going to cut the annual interest in half. And then you're going to compound that interest rate, that halved interest rate, 2 times. That's what compounding biannually means if you have annual interest. Now, GMAT problems will specify this. So let me give an example. Let's say we had $100 invested at 10% annual interest. So it's total 10% interest every year, but it's compounded biannually. So what that means is we take the 10% annual interest and we cut it in half. So you would get 5% of your interest after the first 6 months, and then another 5% on top of that increased amount the next 6 months. Let's do the math. $100 after 6 months, we get 5% interest. That's $105. But at the end of the next 6-month period, or the total 12-month period, we add another 5% of 105. That's the compounding effect. I'll skip the math for you and just let you know that 5% of 105 is 5.25. So we would have $110.25 at the end of our 12-month period. What that means is that compounding earned us an extra 25 cents or an extra 0.25%. That's compounding biannually. You cut the annual interest in half, and then you compound it twice across every year. What about compounding quarterly? It's the same concept, but we divide the annual interest rate by 4, and then we add that amount after each 3-month period. Let's use another example. Let's say we invest $100 at 12% annual interest, compounded quarterly. So that's 3% interest 4 times throughout the year. So again, we take that 12% annual interest rate, we divide it by 4. So at the end of the first 3 months, we would add 3% interest on top of our original $100 investment, and we would have $103. At the end of 6 months, we do that again, except it's 3% of the $103 that we got at the end of the first 3 months. And so at the end of 6 months, we would have $106.09. Then what we do is at the end of 9 months, we would have $109.27. I'm rounding down a little bit if you have a calculator. But basically, what we're doing there is we're taking that $106.09 that we had at the end of 6 months, and we are adding another 3% on top of the already accrued interest. Then at the end of the 12-month period, we would do that one more time, and we would add 3% on top of the $109.27. That would get us $112.54. Again, rounded down slightly. So what does that mean? Well, we got an extra 54 cents or 0.54% out of our 12% annual interest, but compounded quarterly instead of just compounded annually, or instead of just simple interest. So this can help you see the power of compounding, because with the simple annual interest, we would have gotten less. That's the basic idea. That's compounding. So once again, if you're compounding quarterly, you take the annual interest rate and you divide it by 4, and then you do that percent 4 times throughout the year. If you see that on the GMAT, you should know what to do now. Again, I'll leave it up to you what you want to repeat and what you want to memorize, what you want to make physical flashcards out of, or if you just want to use the quizzes at the beginning of each one of these episodes as like your digital flashcard quiz on the go to build your knowledge over time. Other good news, that's all you need to know about the basics of percents on the GMAT. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our video presentation on how to achieve your dream GMAT score in half the normal time. In the meantime, this is a weekly show, so please subscribe and please stay positive and stay consistent with your studies. I'll talk to you all soon.